Hi guys, welcome to Learn Electronics Repair. I have a rather plain looking brown box here, but this actually contains something really interesting. So this is a 4000 volt IGBT transistor tester with voltage tester, diode, MOS triode, MOS LED voltage capability tester. Okay, so what this actually does is this tests the working or maximum working voltage of transistors, Mosfets, IGBTs, and also measures things like Zener Diodes, the breakdown voltage of normal diodes, all these sort of things. So this actually is very useful for various tasks, one of which being to detect fake transistors or Mosfets. And it has a bonus as well, which I'm going to tell you about. So let's have a look first at this item. So we have a little user manual, which is in Chinese or English, so we can check that in a minute. This says it's an LED TV backlight tester, but that isn't really the main use for this as far as I can see. It comes with a few leads there, quite short ones, which don't look to be top quality leads, but this is not an expensive item. So we can see the tester here, just under 20 euros with free shipping. Okay, I get 21% off that because it includes VAT. VAT does not apply here, so I paid a little bit less than that. Probably cost me something like 16 euros. And it describes what they call voltage withstand test. I would call this the breakdown voltage test. Okay, output current settings, it has a lithium battery. Variable output current up to 5 milliamps, it has a lithium battery. Type C USB. Okay, interestingly, they are pressing the test button with a pair of tweezers. So during test, clamp the two poles of the component, red and black clips, confirm polarity, press the start button. If the test voltage value is lower than the voltage value you set, it means the component is already in breakdown state. So we can compare with data sheets and see whether or not our components are actually genuine. We tried this on the live stream at the weekend, and I have to say, this is probably one of the most useful things I've found for 20 euros in a long time, okay? Because it did so many things. Now, this model has the red and black jacks and two yellow ones. So this actually also has, as it says, discharge. So this is also a capacitor discharger up to 1000 volts, safely discharged capacitors, and it shows you on the display as the voltage in the capacitor is dropping. Okay, we have two controls. So this one is the test current and this one is the test voltage. So from 10 volts up to 4000. The spec actually says 3800 and up to 5 milliamps. So I'll set this to quite a low current to start with. We'll just set a voltage, I don't know, somewhere in here. Okay, and we're going to test some transistors. And here are some instructions in English. So for example, the voltage adjustment must be more than 1.5 times the voltage of testing transistor. Example, 1M4007, which has a breakdown voltage of 1000 volts. You want to check yours are genuine. It's saying set the voltage to 1500 or more. Okay, test the transistor with unknown parameters, start at the maximum voltage and current at minimum. Okay, current adjustment, generally set the current to 5 milliamps when testing the electrolytic capacitors, LEDs. Low voltage Zeners, around 1 milliamp. For higher voltage Zeners, MOVs, we can test MOVs, so we're going to play with some of these things. SMD capacitors, okay. And set to 0.1 milliamp when testing sensitive components. So here's some examples. So we have a IGBT here. Set voltage 1200 times 1.5, about 1800, 5 milliamps. Yeah. It's saying short the gate to the emitter. So that's so the gate will not float. Press and hold the blue button, start testing. It will give you the breakdown voltage across collector emitter. Okay. Again, for MOSFETs, the same. So we need to connect the gate to the source to stop it floating. And then we connect positive to the drain, negative to the source, or the other way around for a P-type. And it will give us the breakdown voltage. Triode, transistor, okay, transistor bipolar. So with these, we don't need to connect the base at all because these won't float. It says it can't test the voltage base to collector, but I found that it actually does. We tried this on the live stream, so we will do so, although it says base is not used. Okay, so observe the polarity, NPN or PNP, and press the button. Diode testing, okay. Zener Diode testing, okay. The same with bridge rectifier testing, okay. Thyristors, triodes, so it's explaining that the gate is not used. Okay, so we just test across the main terminals. And the same with the Thyristor, so showing us again the polarity. It's saying connect the positive to the cathode and the negative to the anode, gate not used. And capacitor test, so we just connect the capacitor, observing polarity with electrolytics, press the button, and it will tell us the breakdown voltage. So if you think you have fake components, or for example you just don't know the maximum working voltage of an SMD or something, you can measure it. Okay, so we're going to try these things. Let's give it a go. So we'll start with an IGBT, so 30F124, which we can see from the datasheet. So 30 amps, F is the voltage rating, which tells us it's 300 volts. Okay, so it's a 300 volt IGBT. So in accordance to the datasheet, we have gate, collector, emitter, so positive to the collector, and the gate is connected to the emitter. I've set this to about 1000 volts, I guess. It's on half a milliamp. Let's just try it. 374. So the breakdown voltage is 374. The component is rated at 300, so that's fine, at least on that parameter. Now I have a MOSFET, so 36N50P. Well, that's a different package. We can see different style. I don't see one in this package, but I assume the voltage is the same, okay? Breakdown voltage. So this has a maximum drain source voltage of 500 volts, okay? Let's get the tester. So at least 500 volts. 543. So that is within spec. And if we combine that test with our fake MOSFET detector that measures the gate threshold voltage and the RDS on, those three parameters, I think we should find basically any fake. Here's a very common one, IFPFZHDO. This is the sort of thing you might find fake ones. I have a whole batch of them from AliExpress, so let's try this. So this is a 55 volt MOSFET. Okay, we can see that there. We know we can measure RDS on with the fake MOSFET detector I already built. We can link it to this video. Have a look in the description, okay, if you don't know that one. And that will also measure the gate threshold voltage as well. But once again, let's try the voltage breakdown test. So we're looking for more than 55. So once again, here is our MOSFET ready to be tested. Okay, more than 55. 68. Now you'll notice I don't actually need to vary this voltage. I put it to 4000. It'll still only go to 68 because this is a constant current supply. So once it reaches 0.5 milliamps, it won't go any higher. So it doesn't really matter particularly, I think, what you set this to. You can discuss that down there. And while you're doing that, let's look at some bipolar transistors. Here are some very common transistors if you do power supply repair. So 13007. 13009, okay. This one is a pull, this one is a replacement from AliExpress. So let's have a look at this one and then let's compare these two. So These are high voltage transistors. You often find these in ATX and other switch mode power supplies. So we can look at the specs. 13007. So this has a maximum collector base voltage of 700 and collector emitter voltage of 400. Now, the tester says it can't measure the collector base voltage, but I'm going to try this because we did this on the live stream, and from what we can see, this actually does work. So let's give it a go. So because the base of a bipolar transistor cannot float in the way that a MOSFET gate can, we don't need to connect the base at all, okay? Let's just try it. So more than 400. 477. I'm now going to measure the collector base. So negative to the base. So this is reverse bias. The transistor will not switch on. Okay. But we should be able to measure the breakdown voltage. I'm going to keep this at about 0.5 milliamp. In fact, I'll maybe just turn it down a little bit. Let's try it. So more than 700. 907. We've up to 0.5 milliamp. 911. So it changes slightly. Now you might think, well, we're testing something that says we can't test, so let's just make sure our transistor is still okay. And the tester says it's just fine, okay. Another question is, how accurate is the tester? So I've now connected my multimeter on volts range as well to the transistor. So this is the test that should read somewhere over 400 volts. Let's try. 475. So it's very accurate, at least within a volt. So that is pretty good. Let's look at these 13009. The data sheet tells us 700 volt collector emitter. That's with minus 1.5 on the base. With 0 on the base, it's 400. So I'm expecting we should get more than 400 as the base is not connected. Let's see what they read and let's compare them. So this is the pull. And that reads 0. That one could be short in actual fact. We'll test it in a moment. I have another pull. Also reads 0. Let's try this new one. Okay. 442. So the two which read 0 look like they're short. Let's try those on the component analyzer. Yeah, short. On the other one, short. So connecting a short circuit transistor to this high voltage tester will not bother it. So that's transistors. How about diodes? Well, this is a Zener Diode, so this is the highest voltage Zeners I have available, to be honest. Let's try it. So should be a 120 volt and it reads 124. This is the common or Gordon 1M4007, so we'll reverse bias this. So I wouldn't be surprised there's fake ones of these kicking around. These again from AliExpress. Let's try. So this should have a breakdown voltage of at least 1000 volts. So I'll make sure the voltage, well, it's over 2000, so it should be plenty. Okay, let's look at you. 1558. So that's definitely fine. I have a few Triacs. So what's this one? BT139 600E. I'm fairly sure this is actually a 600 volt one, and I'm pretty confident that the main terminals are on this side and that's the gate, just because that's how they normally are on Triac. So let's just try it. I mean, with the low current, this is not really going to harm things. Okay, so what does it do? 600 volt. 1171. What's the actual rating for this thing? BT139. Well, it says 600, so it should be 600 volt. I'm getting far more than that. That will probably reduce somewhat with the current, but it's way over the spec of it. We can just try that actually. So if we turn the current up, go on, let's give it 5 milliamps. Let's see what it does now. No, still very high. Okay. So these are some small thyristors, PCR 406. The data sheet says the gate is in the middle. I'm not totally sure which way the polarity is. So let's try it, see what happens. We can always try it the other way. Okay. I'll just turn the current down, switch it on. So that reads 0.8. That's reading like a diode junction. Let's go the other way because I didn't know the actual polarity without looking up the data sheet. We'll put it on my tester. Let's see. So we go the opposite way round. Okay. Other way. Just keep this away from the gate. What does it read? 450. So that's above its rating, I would say. PCR 400, I'm sure, is actually a 400 volt. But the usefulness of this thing doesn't end there. So these are varistors, metal oxide varistors. 431, a very common one. I think these are actually 400 volts. So not only can we check if they're genuine, we can actually measure them. So just stick the clips on. Okay. Switch it on. 490 volts is the breakdown of that one. So we can easily measure the breakdown voltage of MOVs or varistors. And then we have capacitors. So these are high voltage disc capacitors, 275 volts, also it says. Let's have a look. I'll just switch it off. I don't totally trust this not to zap me. Although when you press the start button or test buttons when it actually generates voltage. Okay, so let's see. Yeah, 500 volts that's breaking down at. So that's the breakdown voltage, well within spec. So another thing this is very useful for, if you have some sort of fault where you think a component is breaking down under working voltage, this will probably tell you. 1 kV capacitors from AliExpress, yeah. I have a whole pack of them. Can they withstand 1 kV? Let's find out. Are these any good? So turn the voltage up to maximum, I think. Switch it on. What does it do? Oh, these are bad. Turn the current up. 157 volts that's breaking down at. And that's a 1 kV capacitor. So these are bad. That one is at least. So that one was supposed to be 1 kV. Yeah. What else do we have? Let's go for one of the small ones. Okay. Let's see, what does it do? 11 volts. It breaks down as 11 volts. Turn it down. 11 volts. 11 volts. Guys, one box full of useless capacitors. Try one more at random, yeah? Eeny, meeny, miny, that one. No, this one. Why not? Let's change our mind. So this one should be 103, 10 nanofarad, 1 kV, 157 volt. So we have one complete box of useless capacitors, or fake. Okay, interesting. If I'd had this tester when I bought them, I would have got my money back. It's too long now, but yep, fakes. I have another box of 1 kV capacitors from AliExpress. Yeah, let's see if these are any better. So we grab one. These feel a bit thicker, but let's see. Okay. 685, so they're still fake. Not as bad as the other ones, but they're still fake. Try another one. Okay. 158. Aren't you happy to have one of these now before you put these things in? Fake. And we can also use this to test things like electrolytics. Is it really 100 volt? Yeah. And for that matter, if you have just capacitors and you don't know what the working voltage is, this thing will tell you. So we can put this one on here. So this is going to charge up now. Now, it says to set this to 5 milliamps for capacitors. We switch it on and we hit test. And it starts to climb up. Okay. And this should stop at 100 or just over. It's going to take some time to test this thing. Well, it stopped at 3.6. And it's holding the charge. But it won't charge anymore. That's interesting. I don't believe that is actually telling me the truth in this instance. I can discharge it, by the way, so connect it to the discharger. Yeah, there it's discharged down to 1.9 already. Okay. So that looks to be completely fake, but I'm not sure that's really testing that. I think it may struggle at the current 5 milliamps to actually charge this. Maybe the leakage current is something like that anyway. Let's try something a bit smaller. So this is 68 microfarad, 400 volts, okay? First of all, we can check it is discharged. It is discharged. And now we can try to test the voltage. So 400 volt working capacitor. What does it do? Switch on, hold the button. That's charging. So I think either those other ones just have such a low or rather high leakage current. Yeah, it's struggling to test this. Look, 62 volts. So I don't think possibly the test in that respect works for electrolytics. Okay, we can just discharge this. We can just discharge quickly. Okay, so it makes quite a nice capacitor discharger. So I wouldn't say we can use this to test the working voltage of large electrolytics. Okay, so here's a small electrolytic. This is a 25 volt working one. Okay, let's try this. Yeah, 40 volts or so, then it stops 42, okay? But the current is so low, it's not going to cause that a problem. It's discharging now into here. I'm sure if we can actually connect this back into the discharger, we can do them like so. Yeah, it's discharged. And lastly, let's just try a high powered LED. So 5 milliamps, working voltage 20 volts, green's lit, blue 22.6, red 16. Okay, so it tests that also. It also mentions in the manual that this can test cold cathode fluorescent tubes, so the old type of fluorescent lighting and laptops and such like. Okay, so it will do CCFL as well. That's also very useful. I have a LED backlight tester, and I think now that's why this says it is a backlight tester, but not LEDs. Although it would like them. I mean, I showed the high voltage LED, but you probably want more current. My backlight tester is 30 milliamps. But yeah, CCFLs this will do. Okay. So to conclude, guys, I think this thing's pretty amazing. I mean, for the price, like less than 20 euros, this will do so many things that nothing else that I have will actually do. So I think it was just excellent, and particularly the transistors, Mosfets, IGBTs, and other semiconductors. Yeah, this is going to test me in ways you can't. And I swear by the fact this is going to find fake devices, okay? The same with the disc capacitors, which are not high capacitance. It was quite happily testing those, and it would appear I have 2 boxes full of fake high voltage ceramic discs. I mean, they look rather thin, to be quite honest. I was always a bit suspicious of them, and now I know. So guys, hope you enjoyed that. This has the biggest thumbs up I can think of. Just go get yourselves one. There's a link in the video description. It comes with a few different brand names here, but it's the same thing. And let me know what you think. Get yourselves one. Yeah, come back and tell me down there. Or do you already have one of these? And what do you think of it already? Okay, Hope you enjoyed that, and I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.